what I propose is that we take another 10 minutes to do some questions to the three last presenters, and then we will end this webinar. So first, let's go back to Guilherme. There were a question asking if there is a possibility to regain the energy of the exhaust air. Can you hear me, Guilherme? Guilherme?
Yes, I could. I was just unmuting. Thanks so much. No, there isn't because of the mildness of our climate. So being a warm climate that also has a winter that is not very severe, we were able to have no need for heat recovering of exhaust air. As we have a good thermal insulation, we have internal gains that help us heat the buildings. So there is no possibility, and I would even claim that there is no need.
Okay. Okay. Did you consider a mixing ventilation strategy as an alternative to preheating the incoming air? It is widely used approach in the UK, where the climate is similar to Portugal. It's slightly cooler than
Okay. So yeah, we did not consider that as an approach, and I would have to see the system better. This is actually my ignorance to be able to comment on that. So I'm sorry, it's not a very detailed answer, as I'm not familiar enough with that system that's used in the UK. But I will have a look, as I'm sure it's an interesting option.
Okay. How are the regulation devices in the chimney are regulated manually or automatically with parameter?
Okay, so they're manual. You have a lever that you can open and close the chimneys, and then we had instructions about building operation modes, and so they would be left open for night cooling and for winter ventilation, basic ventilation. And the scenario, in fact, where you need to close the chimneys is related to sort of storm conditions outside. So the possibility to adjust relates to two issues. On one side, in the case of the chimneys, that's what I'm referring. On one side, you can have high winds, rain, so stormy conditions you may want to close. And the other scenario is when you have changes in the room use, and you may have lower ventilation requirements, and you want to close. The main adjustment for this system is done through the inflow openings.
Okay. And we will take just one last question for you. Is the overrating criteria based on European codes? Can you explain the overrating criteria more?
No, the overheating criteria is based on the Portuguese code. Okay, so that's a code that has a set of indications for opening area, minimum 5%. And has some recommendations about heights of openings. And it also has an allowance for naturally cooled buildings to have a 10% occupied hour exceedance on a maximum indoor temperature of 25 degrees. So the design criteria used for this building were particular to our regulation because that's what we had to meet.
Okay, thank you. So I'm sorry, we have to move to questions to the other presenters. If you feel frustrated that your question has not been answered, please send them again to Maria Kapsalaki, and she will get back to you with the answer. Yeah, we had almost 250 participants at some point in the webinar, so it makes, of course, a lot of questions, but that shows that it was a successful webinar with a lot of interest, so that's good. So let's move to the questions to Maria Colocotrani. So do you know how much energy the fan in the cool-fast system was using?
Yes, actually, we measured it and did a few calculations. And for this particular seminar room, it was, depending on the year, it was between 9 hours per year for the whole room. So, this includes the fan and the motors for the dampers and so on. So it is very little energy that it is used to operate the system.
Can you just repeat the value, because I think there was a
75 to 90 kilowatt hours.
Okay.
Per year, the whole year.
Thank you. Very good. As there is only one inlet and one outlet, where is inside temperature taken? Did you monitor it at various distance from the inlet, outlet, or windows to assess the variation?
Well, yeah, the system itself, it measures only temperatures on inlet and outlet. So the system is controlled from these temperatures plus the internal space at once. We had put additional sensors, temperature and humidity, in many places, in about a few places in the room at seating level. So yeah, we had quite a few spots of measurements within the room.
Okay. What kind of program was used for this simulation?
The simulation, actually, we use ISV that has got a plug that the user can simulate the cool phase system. And also we use Fluent ANSYS for the CFD simulations.
Okay, and one last question for you. What would be the maximum outside temperature at night to keep the system efficiency?
Yeah, well, the PCM that it is used, it is a salt hydrate that has got a solidifying range between 19 and 21 degrees C. So the night temperature needs to be certainly below 19, so I would say below 17 degrees C in order to be able to solidify the PCM.
Okay, so 17 degrees.
Yeah.
More or less.
More or less, and hopefully the less it is, the more efficient it will be. Yeah.
Okay. Thank you very much, Maria, and we will move to some questions for Paul also. We have only 1 minute left. So, Paul, do you know if surveys have been achieved concerning the increasing noise level and subsequently discomfort when using the increasing flow rate strategy with mechanical ventilation?
Thanks for the question. From the top of my head, I don't know that was specifically done. There's 14 case studies, so it's difficult to try and remember each of the case studies and what level of performance evaluation they did. So I would say that it's a case of, I don't believe that there was any detailed surveys done on the increase in noise level and subsequent discomfort. The focus was very much on the thermal environment in most of the studies, but it's something that we can certainly check out and have a look at and maybe come back to you.
Okay, so do not hesitate to send an email to Maria to ask again the question. Yeah. What is the part of residential examples in the case studies?
I'm not sure specifically what this means. What is the part of residential? There's 4 residential case studies in our 14 examples. 2 of them are homes and 2 are sort of apartment buildings. So there's 4 residential examples in the case studies. I'm not sure if that answers the question. We're working, or there's we've done some work. Sorry, there's 4 in our case studies, but if you look back at the state-of-the-art report that was done at the beginning of the annex, there's also another number of residential case studies there. And also, if you look at subtask B, they also have collected data sheets on case studies that aren't as detailed as the ones we did in subtask C. In total, I looked at this recently because I was collating them for another project. There's 16 residential examples across the different documents on the website. So there's over 16 residential examples, but we only had 4 that included the performance evaluation.